Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. We got a spacecraft panel. The emissivity is 0.61. The solar absorptivity is 0.21. The radiation is 1001 watts per meter squared. We want to find surface temperature. Assume that the emitted and absorbed energy is equal. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. This is similar to 2-103, except we're using a different formula, but the steps are very much the same. Okay, step 2, list all the given variables, find the unknown. So we got the alpha, the epsilon, the outside temperature, we assume it's outer space, and this is the radiation. Step 3, find the surface temperature formula. So we've got the solar absorbed heat transfer rate on one side, and then we've got the heat transfer rate on the other side for radiation. So we've got the formula. We expand out the temperature. I've written it out as surface and space, so students don't get confused. The alpha is given. The areas are cancelled out, as you can see. The epsilon is given. Sigma, we can look that up in a table. We're trying to find the surface temperature, and we're going to assume outer space is a certain temperature. Step 4, find the Stefan-Boltzmann constant, sigma. You can search that up on Google or look it up in a table. So the trick to remember this one is 5, 6, 7, 8. Make sure you put your decimal between 5 and 6. And then as for your 8, just know that it's 10 to the power of 8. Okay. So step 5, find the surface temperature. So we just plug and play. Now, the only thing that we have to assume is outer space. So we are going to assume that it is 0 Kelvin. Alright, so once you plug this into your graphic calculator, note that this is to the 4, apologies, and anything 0 to the power of 4 is still 0, so you can leave that as is. But for the sake of completeness, we'll just make sure it's correct. Okay, so once you plug that into your graphic calculator, your solver, you will get the temperature of 279.21 Kelvin. So that is your surface temperature for your panel of your spacecraft. Disclaimers, the method is correct, however I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Before we leave, I highly encourage you to save this video onto your PC, just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things happen. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. Click on the icon in your taskbar. If it's not in your taskbar, go to your Windows search, type in snipping tool, open up the program. Click on video option, click on new. Left click and drag the rectangle. This is just an example. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish. Hit the red square in snipping tool to stop recording and then save your video. Thanks for watching. Like and subscribe. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.